Exactly. And same if you want to. Yeah. I'm glad you found the community.
Well, I don't know about that. You're good. 3 minutes after, so
You're good. You're good.
we'll just rock and roll.
Yeah. Hello, everybody. Welcome. Welcome, welcome, welcome. Hopefully you can hear me okay. My bad for being late. It's me again. If you saw my first presentation, woo, raise your hand if you saw my first one. Yes, virtual high fives all around, online. Sweet. Well, I'm not Jonathan Wright, obviously, so I'm filling in for Jonathan. Unfortunately, I didn't have a presentation around what they were talking about, so I'm going to talk about my stuff instead. I figured, why not talk at a testing conference about how you actually build and test these things? Because I think that's been a very common question that I get almost daily, is how do you test LLMs? How do you test AI? So that's what we're going to demystify today, so let's do this thing. Really quick, I've been in AI and ML for about 8 years now. It was ML, of course, before. So I've been in this, building them, testing them. I kind of made my name, I would say, by using ML and AI for testing and testing them as well. So like on Test Automation University, for example, if you know of that resource, mine was the first AI presentation on there, first course on there for testing ML systems. So I've been doing it for a long time. I'm really excited about it, really passionate about it. And I want to bring people along for the ride. So to start things off, there are going to be some slides that look like this throughout the presentation. Every time you see one, what I want you to do is yell out as loud as you can what the name of that movie is. So let's try it out. 3, 2, 1. What's this movie? Nice. It is Lion King. Well done. How about this one? Lord of the Rings. Yeah, you're so good at this. See, you take an emoji? Awesome. I promise that will be relevant later on in the presentation. It's not just a fun game for me. All right, so MLOps. First thing I'm going to demystify. MLOps is DevOps for ML. Who would have thought? In the AI space, we are catching up to a lot of what we do in traditional software. So MLOps was a big thing. We're like, wow, what if, imagine this, what if we deployed little things and tested it kind of continuously so that way we could track it? What if we versioned things? And everyone else in traditional software is like, yeah, like, there's like Git and stuff. We didn't have that at the beginning. We were using Jupyter notebooks and things, and a Jupyter notebook would turn into an API server all of a sudden, and there was no, it was just bad. It was bad. So the AI space is catching up, but we're catching up very fast. So in MLOps, you have the idea of machine learning. That's the data science stuff. You have data engineering, which is how you harness it, collect it, transform, normalize, all that good stuff. And then the DevOps side is how do you actually deploy, how do you monitor, how do you iterate, feedback, that kind of stuff. If you were to look a little more closer within that, an ML process looks like this. You start with this data ingestion. You need data of some kind to do something with ML, right? So you get data in, you label it in some way without getting into like unstructured versus structured stuff. Just normally you want to label your data in some way, even if it's just metadata, and then you do a bunch of experiments. I would actually argue that people in the ML and AI space test more than testers do. It is literally constant, and we have tons of different mechanisms and tools that we use to do this. So I'm gonna show you some of those things in this presentation. The term AIOps came out because imagine DevOps, but it's for AI. The joke writes itself, but it's basically the same thing. But instead of dealing with machine learning models and training them yourself and everything, you're probably using AI models that already exist, think like the LLMs, for example, and then building processes on top of that. So it's not as data science-y, it's a lot more engineering focused than ML engineering. But again, I won't get into semantics, just know that this is what we do in the AI space. So let's say that we get hired by this grocery store chain, and the CEO says, your job is to use AI to predict how much customers would spend. This is the data set that you're given. One person came in, spent 10 bucks, 2 people 20, 4 people 40, awesome. So the question is, how much do you think 3 people would spend? 30, everyone's quiet, 30 I think? It's 30, it's 30. But is it guaranteed that 3 people are gonna spend 30 bucks? No. They might come in, they're just buying some drink. They might come in, drop a dookie in the bathroom, and they don't spend anything at all. It's not guaranteed. So then how are you supposed to test this? The prediction is 30, but is it guaranteed 30? No. But what if the AI said, I think 3 people should spend $1 million? Would you go, well, that's kind of ridiculous? No. That's a pretty clear fail. But if it said 29, well, that's pretty close to 30, so that's better than $1 million. Interesting, interesting. So the first tip that I have for y'all is defining the problem. This goes for everything in software, but in AI especially. Define the problem. Too many people want to use AI, they figure out how to do something with OpenAI's SDK, and they realize, wow, this is really easy to actually call an AI to do something. It is actually, it's not that complicated. And so they start going crazy with, well, I could do this, and I can do this, and I can do this. Awesome POCs, I love brainstorming, I love the experimentation, but when you actually want to turn an AI product into an actual product, that's very, very different, right? Little toy thing on my laptop versus thousands or millions of users actually using my stuff. So what if we changed our problem statement to this? We have the same data set. Do you think that we can solve this challenge with the current data set we have? Probably not. What are some data points you think you would need in order to do this? Any ideas?
Stock level.
Stock level, yeah, stock level. What's being sold, shelf life, like there's all these different things that you go, that's not enough at all. If we're trying to prevent understocking and overstocking, that's nothing. I can't use that to solve that challenge. So immediately the data is going to tell you what you can and cannot do, right? You're going to need different data to do this. So when you define the problem, what are you trying to solve? Who is the solution for? Is it for the general manager? Is it for the team that stocks every single night? Is it for the region? Is it for the... Which parts of the solution require AI? The less AI you have, the better, because once you add AI, complexity kind of skyrockets a little bit. So the less AI you have, the better. So if you're going to use it for the parts that actually need it, right? And then how do we measure success? If you're at my first presentation, I think some of these slides might actually feel very similar. That's on purpose. So normally with this presentation, I have a demo that actually show code and everything. We use AI to actually recommend songs from Spotify. Say, I like Taylor Swift, and then it can give you songs that are related to Taylor Swift. Fantastic. So we'll still use it, but I won't be able to show code. Don't have enough time. All right, name this movie. So quiet. I mean, it is Jurassic Park. You win. You win. If you get it wrong, by the way, you don't lose any points. There's no points here. All right, so the next tip is mapping the pipelines. You've now heard in multiple presentations that visualizing things and having conversations, iterating, modeling, these things are very useful. They're very valuable. Why? Because you get an understanding and alignment with the rest of your team of what the actual things are. So for example, let's say I drew this. The user is going to ask for a song, AI is going to get songs, and then return the songs to the user. Great model, right? No, it's terrible, because how? How is the user asking for songs? Is this a chat bot? Is this inside of Spotify? Is this a Chrome extension? Is this a mobile app? Just saying user asks for songs. That's dumb, that doesn't work. How does the AI get access to Spotify? If you ask ChatGPT right now, give me songs from Taylor Swift, it will do its best, but I want it from Spotify. It will say, I can't do that, because it doesn't have access to Spotify. And then return the songs to the user. Cool, like is this just like a playlist you're creating for them? Like is this just a bullet point or bulleted list of things? What is that? You have to define that better. Hopefully you can see this, a little small. But what if you visualize it this way instead? Where we say it's a chatbot UI, where the person's gonna be able to ask whatever they want. It's just a search box, right, basically. They can ask whatever they want. The AI needs to parse the artists and the number of tracks out of it, and then say, do I have enough context? If no, it should tell the user that. I like Taylor Swift. You didn't tell me how many songs you wanted from Taylor Swift, just that you like Taylor Swift. It should end. Well, boom, that scenario I just posed, I like Taylor Swift, sounds like a test case, because now I can write that down. What happens if I say I like Taylor Swift in this system that I created? I expect it to go down to the orange box, but does it? Now we start to create some scenarios, some test cases, you get the idea. If I have enough context, go to the purple. Use Spotify's API in order to query songs, and then use those songs as context in the answer, respond back to the user. Awesome. Even this, you probably have more questions. You said, give me a formatted answer. What is that formatted answer? Oh, well, it looks like this: a name, artist, album, and preview URL. And you have more questions and more questions and more questions. It's great to be a tester. Look at us asking all these questions. So, some things in this. What data do we need and from where? Notice how the input's from the user, but we got to get context from Spotify's API. So we get real-time songs, not just stuff that used to be there or is not. What context is required? How do we get these for each step? And how would we integrate this into our system? And then I put these in blue because as testers, you're usually asking the thing as well. What are some potential risks with this thing? It's just a chatbot, which means that there's an infinite number of inputs that can go into that thing. So the testing surface area is pretty huge. And then what are some examples and scenarios? We haven't even built anything yet, and I'm already coming up with scenarios for us to consider as we design and build this thing. The next tip is to leverage observability as soon as possible. Now, I would also say this for traditional software as well, but in AI, this is mandatory. You really can't get away from this. Why? Because you ask ChatGPT something, it outputs back. Why did it give you that? What was it thinking? What did it have as context to answer that? What ground truths did it have? There's all these questions you have of what happens behind the scenes, but all you see is text in, text out, and everything behind the scenes is invisible to you. So in AI, we use observability to say what's actually going on behind the covers, what's going on with the AI and what it's doing. So let's use this example here. What are 5 good songs from 21 Pilots' latest Clancy album? If you're a 21 Pilots fan, let's go. This is what the AI responded back with. It's like they don't have an album called Clancy. They have a song named Clancy, though. Who thinks this is a good answer? This is a high-quality response from the AI. Nice, nice. What gives you that indication that it's a high-quality answer? Yeah, so basically it looked at different songs, gave information about it. It didn't just make something up, right? But it did. It did make something up because the album Clancy does exist. The AI was trained before the album was released. It doesn't know that Clancy exists. So it's correct that it doesn't know, but it's wrong in my context as a user because it does exist. Why didn't it know that, right? Very interesting. If I started testing this thing and I wanted to see, well, let me ask it again with a different model, or let me make sure it's trained to the latest date and try again. Well, how am I going to keep track of all these different tests and experiments that I'm doing? That's where observability comes in. So this is a tool called Lanksmith. That's one I like to use. There's many. But this one, notice how each row, this is a conversation or a trace. I get some information out of the box. For example, latency. How long does the conversation take? When I input and get an output back, how long did that response take? I get that information. How many tokens were used in that? How big was my input? How big was the output? Right? You might say, yeah, for something like, give me some songs, I probably want a small response. Just here's some songs, and that's about it. I don't need it to tell me a novel. Well, songs were based in this, and it goes on this massive novel of a response. I don't need a huge response for that. And then even the total cost. Every time I ask for songs, it takes 0.006, 0.008 pennies. It's actually pretty cheap to work with these models. But what if I have bigger responses, or I'm using a multimodal model, or vision, or anything like that? Well, it might be more expensive. How am I keeping track of all these costs? So this is the type of stuff that we, as testers, can use to start evaluating how the AI is doing with our problem. So yes, leverage observability as soon as possible. It helps you observe, measure experiments. You get things like costs, performance, tokens, and even scores, which we'll get to here soon. And then even compare different models and flows, because you're not just going to put GPT-5 on everything. You might have some smaller models or some more specialized models, maybe your own trained models. You're going to put different models. You're trying to pick the best one for the job, right? So many options. Lanksmith is the one that I like to use myself, but there are so many. There's like 20 or 30 of them, not even kidding. Most of them are free open source, by the way. So just a few examples for you. All right, what about this movie, y'all? Ah, nice, I'll try to trick it. It's Castaway. Well done, well done. How about this one? Greatest Showman. What if you said Dumbo? Would you be right or wrong? There we go. Let's go. It's getting there. It's getting there. All right, the next tip is adding controls to the AI. There's a myth that the AI is uncontrollable. That's not true. You actually can control the AI quite a bit. Is it perfect control? Unfortunately, no. But you actually can add a lot of controls to AI. So we're going to go and do the topic of AI agents. Who's heard of agents before, by the way? Fantastic. Hopefully now it's more common knowledge. Even a year ago, that was the hot thing. So hopefully now it's a little more common. So the human eval benchmark, this is a benchmark where let's pretend there's 100 coding challenges. And you put a model through it and you say, how many of these coding challenges can you get right? GPT-4 by itself got 67% correct, which is not bad. These are very difficult challenges. But getting GPT-4 and making it an agent, they got 94.4% accuracy instead. Same model, just making it agentic instead of just a regular chat model. Very interesting. So if you want to build agents yourself, here's some things that you can work with. LangGraph is the one that I like to use, but again, there's many other tools that are out there. Pydantic AI is one that I think is very popular right now as well. Deep Agents just came out as well. There's quite a few. But yes, so let's jump into AI agents a little bit, because if you don't quite understand that difference when I said the chat model versus an agent, let's go into it. There are 5 main things that make up an agent. The first one is the model, or the brain of the operation. You have to give it a model to do something, right? So you have LLMs or an SLM. LLM is large language model. SLM is a small language model. Or you might have some specific OCR or some specific ML model that you're using yourself, like a small Dockling or something. I don't know. You need a model to kind of drive the brain of this agent. The next thing is a prompt. These are the instructions that you're trying to give the model to do something. By the way, when we say AI engineering, it's basically how can we automate something with the AI. So your prompt basically becomes your automation script. Very interesting, by the way. Very close to test automation, where you have like the playwright or the PyTest or whatever, like as your script, and it always is the same thing. Your prompt basically becomes that script. So natural language automation, basically. The third part is context. You may have heard things like RAG or memory. These are the things that basically let the AI have context into what you're talking about. When we said Spotify, it doesn't have access to Spotify. So we need to go out to Spotify, grab some songs, bring it back as context to the AI, then say, oh, well, now I know what songs exist. Let me be more accurate in my response to you now. Make sense? The fourth one is abilities. You need the agent to be able to do things. So that's the difference. Like with ChatGPT, when you say like, I want you to create this Excel spreadsheet for me, if it was just a chat model, it couldn't do that for you. It could be like, well, I can kind of give you instructions for how to do it yourself, but I can't do that. I'm not an agent. Or now, ChatGPT is agentic, but it has abilities, things that it can do. So you may have heard of like MCP, for example. Who's heard of like Playwright MCP? If you haven't, Google that. But Playwright MCP is the way for you to provide tools to an agent so it can do Playwright things on a browser. So you can say, hey, agent, I want you to use the Playwright MCP. Go to this URL, and I want you to create automated tests for me in Playwright. Because it has Playwright MCP, it will actually do that. And it'll be much better than if you didn't give it the tools to do Playwright stuff. The last thing, which is one of the most important, is evaluation. Giving the agent the ability to reason or think. The reason why I did so well in the previous human eval is because you have a coding challenge. It says, yeah, let me try to solve that. It outputs some code, and it actually ran the code. It has the ability to run code and run tests. It saw, oh, the code I didn't work. So let me use that as context. Here's a failed attempt. Let me use that to learn. Let me try again. Let me update the code a little bit. Let's see if this works. Oh, that didn't work either? Okay, now it's learning with all the failed attempts it had until eventually it gets one that checks the mark and it passed that human eval test. Sweet, I got the right answer, on to the next challenge. That's why it got 94.4% accuracy, because it had the ability to evaluate itself. Woo. So this thing here, our diagram, this is actually an agentic system. Why? Because it has the ability to reach out to Spotify and actually query songs. So this is an agentic architecture that we have here. So with agents, use proof of concepts. Again, it's easy to get something going, but you want it to be as, you want to have a baseline that you can use to say, yeah, if we spend more time and energy in this, are we doing it better? Are we doing it worse? Having a baseline is like a fundamental thing in any science or data science kind of theory. You want to use the cheapest and fastest models first. Hopefully that just makes sense. It's probably your money that you're using to do this, so be nice to yourself. If it's not your money, use the slowest, most expensive. No, I'm just kidding. Then use schemas, excuse me, and structures for the inputs and outputs. So you can actually say, AI, I want you to output JSON in this exact format. You can do that. And that's especially important when you want the AI to give you a list of songs back, let's say, and you want to put that in the UI. Well, the UI needs to have the data in a specific shape to show it appropriately. So you can actually control the input models and the output models for the AI to use and have control in that way. And quick shout out, because I know we're at Zion's Bank, you can test models locally and privately. So you don't, like, if you're like, oh, I can't use OpenAI because of data, whatever. Use something like an Ollama or an LM Studio where you can actually download models onto your machine that is completely secure for just your machine. It doesn't have access to the internet, so you can't leak anything. Obviously, look at the model card to make sure the model is one that you like. Maybe you don't want to just use like DeepSeek in a Chinese model because you don't trust them, or maybe you're like, nah, it doesn't really matter to me. Who knows? But read the model card first, and then download the model, and away you go. Very secure, very private, very nice. The next tip is continuous testing and evaluations. Let's jump into this one. This is the last one, I promise. Name this movie. Incredibles. Yes. Is it one or two? Just kidding. I promise, that's the last one. The reason why this matters is because this is actually part of a benchmark that Google does. Google has a massive collection of data sets to test AI models. So have you all ever seen like where they'll say something like, this model is 10% better than the previous model, or you've probably seen like benchmarks, things like that. Well, they use literal benchmarks to get those numbers and show that. They're trying to show progress and improvements. They're using data to give you that information. So this benchmark from their big benchmark data set is called the emoji movie test data set, where you get an input, what movie is this emoji described, and they give you a sequence of emojis. And then they have two different ways of evaluating. The first one is the target, the very bottom part. That target is a binary pass or fail. In testing, we would call that a hard assertion. It either passes or it fails. It either is interstellar or it's wrong. But the second object there that target scores is a range. Interstellar would be 100% or 1. But if it gets Toy Story, that's not even close, so 0. What if it said The Martian? Is it 50% right, 60% right, 75% right? Well, now you're dealing with AI, where we deal with ranges, gradients, boundaries. It's a very different beast to test, but a lot of what we do in AI testing is very similar to what you already know. So let's use this. This is a test automation example using PyTest, where I have all these different emoji examples. Right now it's only 2 because it fits on a screen. But you can imagine I could have hundreds or thousands of these inputs. You parameterize a test, so that way you can have all these examples and feed it into one test function. And then, did it get it right? So for the first one, that input, the output should be interstellar. The second one, it's a clown with a balloon. It should be it. Did it get both of them correct? Did it get one of them correct, or 0 of them correct? It's either 0% right, 50% right, or 100% right. Now we have these gradients. In a test pipeline, like a CI pipeline, let's say, you can actually do these soft assertions, where you say, if one test fails, I don't want to fail the whole pipeline. I actually want to see how many tests fail so I can get a failure rate. If the failure rate is below 20%, that's good enough, deploy. Or maybe 90%. But you have these gradients you can use instead of just saying, oh, one test failed, it didn't get it said something else. Fail the whole pipeline. That doesn't really work well in the AI space because it's not always going to be 100% accurate every single time. So ranges, gradients is what we use instead. And this is just a PyTest example. So this is no AI code here. This is literally just PyTest. Without proper testing, problems can happen. On the left-hand side here, we see a person moving a turtle. This is a video. I took a screenshot of it, but it's a video. The person's moving a turtle. And the AI, a computer vision model, is supposed to determine what is this thing I'm looking at. I know it's hard to see, but that red bar, that's almost 100%. The AI thinks this is a rifle that it's looking at. A rifle. Almost everything else down there are gun related, by the way, too. So it really is looking at a gun. It's like, this is a gun, it's a rifle. I'm pretty darn sure of it. Without observability, we would have no idea why the AI thinks that's a rifle. With observability, we can basically put on the glasses of the AI and say, what the heck were you paying attention to, and look through the thing, right? Looking at it, what we see is that the AI looked at two things in particular. Number one, the shape of the hand. Number two, it looks like camouflage. Because of those two things, the AI said, this is a rifle. I've seen tons like it. And we're like, well, you're dumb, AI. Yes, it was dumb in this case. But at least now we have the information so we can go back and tweak it and be like, oh, shoot, maybe our training data set's just full of guns. Whoops, we need more turtles in there. Who knows? This next one is also computer vision. They have a stop sign. This is for self-driving cars. They bought a stop sign, showed it different ways, upside down, to the side, and the AI said, stop sign, stop sign, stop sign, stop sign. Very good. One of them decided, well, if we put stickers on there? They did that, and it saw this as a 45-mile-per-hour sign. So the AI is going to speed right through that stop sign and probably kill someone. And you might go, well, Carlos, who puts stickers on a stop sign? Have you been in the streets, y'all? Have you been to the streets? There's graffiti on there. There's stickers on there. There's people that have kicked the thing over. It's on the floor. It's pink. There's lights around it. Like, there's all these different variations of a stop sign. So only testing with one perfectly clean stop sign, wouldn't you say your data set, your testing data set is kind of biased just because of that? Yeah, so as a tester, you go, let me see if we can actually drive it through a very controlled neighborhood and see if it goes through there. Who knows? But now you're thinking like a tester in this space. The company I used to work at previously was called Quality AI. They're actually here in the back, woo. And we used AI to generate tests for you. But we needed to come up with a way to say, when we generate a test, how do we know that the test is good? Is that a good test case? What is a bad test case? Are we just like make 1,000 test cases and that's not really helpful? We had to come up with different ways to actually measure this. So my team actually sat down and said, well, what makes a test a good test case? I searched the internet, y'all, like no one's business. There's nothing in the internet with this. We had to say, well, a good test covers something valuable. Oof, subjective much? It has a good assertion. Oof, subjective much? It's useful. You get the idea. It was very hard for us to objectively say, this is a good test case, this is a bad test case, this is a great test case. It was very hard for us to do. So we said, well, we don't have data for this. So let's have my poor QA team at the time. Every test case that the AI generates, we want you to go in there and manually label on a scale of 0 to 5, did it cover something good? 0 is terrible, 5 is great. Was it actually useful? Did it have at least one good assertion? Did it have a false positive or negative? Was it readable? What they had to go in there and literally put in the numbers. It was a tough 3 months. I was doing it too. It was a tough 3 months, and they even put observations on the right-hand side as well. The reason why we did this was so then we could make what we call an LLM as a judge. We could have the AI evaluate our test-generating AI. Because I didn't want my humans, my testers, to be the rest of their lives putting 0s and 5s and 3s and 2s in the spreadsheet. No thanks. The lines start to blur. You forget where you're at. No, thank you. So instead, can we get enough information gathered and give that to another AI and say, here's what make good test cases, great test cases, bad test cases on a scale of 0 to 5. And you evaluate the automated tests that are getting generated and give us a score so we can evaluate it. This worked extremely well. In Langsmith, you have this ability, most observability tools have this, where you're able to specify a judge. In this case, we say we're going to use GPT-4o, maybe use GPT-5, right, whatever, you pick a model, and then you say, what is the thing that you're going to evaluate? In this example here, you see hallucinations. How good does the model not hallucinate? Or how often does it hallucinate? How bad is the hallucination? Because that's also a gradient, right? Give us a score, and then we can evaluate it. There's a whole process in that, but this is the part I want to show. We were then able to compare different models, different flows, different ideas. So if we take this example, what are songs similar to 21 Pilots and their latest album called Clancy? We could feed these different scores, these different metrics through this thing and say, well, latency-wise, GPT 3.5 and Llama 3.2 are the fastest. They look the best. So look at GPT-4o. It was the slowest and the most expensive. This is on the model attributes, how good the model is. But that's not the same as quality attributes, which is the problem that we're trying to solve. How good is the AI in solving our problem? That's very different. So in this case, hallucinations. We want to make sure when it generates a test case, it's not making up a feature that doesn't exist in their application. That would be pretty bad. So how much does it hallucinate? Relevance. How relevant is the test, and how reliable is it? These are now different attributes that we had to define as testers and then throw it in here. So now we can see that 4.0 is actually pretty darn good. It's slower, but it's more accurate most of the time. So are we okay taking that trade-off? Slower model, but it's better quality, or do we want speed and more so-so quality? That's something that we had to determine, but we now have the data to help us make those decisions. So in testing and evaluations, in the AI space, soft assertions make a lot of sense. You can still do hard assertions, of course, like I showed you in that example, but failure rates, scores, gradients, that's usually what we're using instead of how good is it and is it good enough? If it's 90% good, is that good, or is it 95% that's better? You have to come up with that number. And I also want to call out that you can use the same tools, techniques that you have as testers already. You can apply a lot of those things to the AI space as well, and I hope that you see that in everything we talked about. I talked about plans, I talked about scenarios, test cases, those types of things. You can use all of that in AI as well. So when it comes to evaluations, and the reason why we call it that is because of the gradients, you define quality attributes and how to score them. It's a challenge, but you have to do it if you're going to be in the AI space. Automate the easier checks, of course. You saw PyTest can do that pretty nicely, or whatever test framework you use. You can use AI models to evaluate other models. Again, that's that LLM as a judge kind of technique. And there's many evaluation tools for AI. I showed line graph, but yes. The smaller you keep the scope, the easier it is to test. So that leads me to the last tip that we have. You can use the UX to also control the AI. Example time. Google Translate translates things, obviously, right? The left-hand side, you have Turkish, which doesn't have gender, where in Spanish, you have el niño, la niña. There is gender in my language, right? But Turkish doesn't. So you get this Turkish thing, you translate it to English, and it immediately assumed that she is a nurse and he is a doctor. Well, that's showing a pretty clear bias, right? That's a harmful bias right there. What about this one? Casey is my friend. Well, how do we know if Casey's female, male, non-binary? If you don't know, how is the AI supposed to know? It can't. So you can try to force the AI to do something right, but what if instead you use the UX? What Google did was, we're not going to try to guess your context. Instead, we're going to give you both translations, and you pick the one that fits your context, because only you know it. In the Spotify example that I was going to show, instead of just having a field where they can type in whatever they want, what if instead we had a database of the artists that we know we support? And we force the number of tracks to be there, so they can't mess that up. We can even control the number of tracks. It has to be at least one, and no more than 50. Well, now we're taking a lot of the guesswork for the AI to come up with, and we're controlling what the AI can and cannot do. We're giving those constraints, those controls, those guardrails. All right, y'all, that's it. Thank you so much for your time. I'm happy to answer questions now. Woo! We went through it. Woo. My voice, y'all, my voice. Hopefully I demystified AI a little bit for y'all. Hopefully it's testers.
Thank you, Carlos, for your presentation. Can you share some thoughts on what do you see as the so-called common bugs in testing agents or agentic system? So in a way, we can focus on, also comment on how to look for those bugs.
Okay, so like what are the most common bugs that you see? It's a difficult question because each solution is so different, right? So like the Spotify recommender song, like the Spotify recommender thing versus Google Translate are two completely different types of products. So you would see different patterns in both. So for example, the Spotify recommender one, the most common thing that I saw in that example as I was building it was the fact that it would grab songs from Spotify, but it wouldn't know what songs to grab or what search terms to use. So if I did something like Taylor Swift, that's well known, it had a much better idea, pop and rock, and some other people might go, she's not pop rock. But that's the thing, right? Like if I'm not a Taylor Swift expert, how do I know what categories of songs that she's in? The AI had the same problem. For people that were really well known, Michael Jackson, the AI was really good at it. But once I started getting to less well-known artists, it started getting really bad at it. And so then how would I go about resolving that? And that's why I mentioned that UX thing of maybe put the artists that we know really well, and we can keep expanding that list as we get lesser known artists, as we get better context for those types of artists. Yeah.
With outside of the LLM-based areas, which is you are correct, what do you see as like other communications bugs that, when agent talking to one another and at the APIs level or at the MCP level or things like
for
that,
sure.
beyond the LLM issues?
Yeah, so I mean, again, like it's a big question just because it depends on your architecture, what you're building. So you mentioned like MCP versus agent to agent. Like these are two completely different things. And so I think you have different challenges in both of them. For the MCP thing, it's either you're building it or you're using someone else's MCP. So let's say you're using someone else's MCP, they define the rules for how your AI uses their MCP. So normally what I tell people is if you're gonna make an MCP, build it yourself first, because then you have control of the prompts, you have control of the context, the functions, and different things that you give to the AI. So if you just give, let's say Playwright MCP I think has like 25 or 30 tools out of the box, you can give all the tools to it. But if all you really needed was the click, why are you showing it everything it can do? Just say like, hey, this is a click, so here's the click tool. So there's lots of like, if you just give everything to the AI, that's where you're giving all of the guesswork, all of the decision-making to the AI, and that's a problem. So you want to take as many of those decisions as possible and make them yourself, and then let the AI do the part that you need it for. That's why I say like, don't have the AI do everything, because it can, but then you're gonna have a hard time controlling it and evaluating it, because there's so many points of failure it can have.
Thank you.
Yellow.
Thank you.
Sure. Hello. Okay. I have a question around evals when you spoke about using AI to generate test cases and doing a human eval by labeling what is a good test case, what is a bad test case. What kind of criteria? There are 2-3 questions I have. I'll club it everything around evals so that you can answer in one go. So what kind of criteria did you consider when doing human evals? And when you use that label data to do the eval for the new test cases which are generated, did you provide additional context around the new criteria which you want to eval against? And would you use the same model to do the evals the model which you have already used to create the test cases? Or what's your take on using different models for doing evals and doing actual tasks?
Yeah, so I wouldn't use the same model to evaluate itself. In the ML world, we have a thing that we call overfitting, which is basically when you add so much bias to the AI that it will usually say something. So for example, with that turtle example, it was guessing gun when clearly it was a turtle. But in the training data set it was given, it probably had a lot of things related to guns of some kind and fewer examples of animals, especially turtles. So to say, my gun model, can you evaluate that it's a turtle? It's already biased, right? And so you probably want to have a different model with different instructions and different context to evaluate the model that's actually under test, right? So I wouldn't use the same one just so I have more accurate evaluation results. Going back to, I think the other part of your question was around this, right, of like the metric. We had to come up with this, right? So I shared this because it was like, yeah, we started by just brainstorming what makes a good test case. And that was a whole conversation in and of itself. We had to come up with different things and say, well, let's use this one. This will be easier for us to measure. And then eventually, that's going to start with this. But we iterated on this. Like, this is just an example. But we iterated on this and had even more things as we started learning more ourselves about what makes a good test case. And that helped with the AI as well. When we were using let's say the AI evaluator against the actual AI under test, we had to test the AI evaluator to make sure it was evaluating things well. And so it's like, well, who tests the evaluator that tests? You can get into that crazy chain, of course, but that's something that we had to tackle ourselves. We defined the metrics, we defined the scoring, we defined the evaluator to eventually test our system.
Thank you.
So a lot of brain power, y'all. A lot of brain power.
Hello. Carlos, very good presentation. Really need to appreciate that. From the question perspective, chatbot testing You spoke about it in a, what are the strategies normally adopted? What are the metrics? How the chatbot testing is done, especially when there are a lot of dynamic prompts that people will have, right? So if you can
Yes.
talk about it a bit, that will be really helpful.
So remember this part where I talked about the actual problem statement? You have to have this, because if I don't know what I'm actually trying to do, how do I know what I'm supposed to be testing? The issue with the chatbot is that if you just give it like, you put a wrapper on top of ChatGPT, let's say, then you're basically testing all of ChatGPT. And you don't really want to do that. So you're probably going to ask, well, if we're adding a chatbot to our UI, why are we adding a chatbot to our UI? What problems is it actually trying to solve? What processes or things it's supposed to improve? You're adding a chatbot, but that might be, if you have no goal behind it or any problem statement, you're adding a chatbot for no reason. And I hope your company's not doing that. Maybe they are, but they usually have purposes around it. Well, it'd be so much easier if they can ask the AI to generate this query for me. Well, now you know. This is a SQL query generating AI. And now all your test cases will shift. And now you're going to be testing it for query kinds of things. But if it's just general purpose, well, then you have an almost infinite space that you're trying to test, and that's really hard. So that's why I said keep the scope as small as you possibly can, so you know what you're testing. It's not just a chatbot. Why did you make a chatbot? Why are you putting on your application? What are the 5 main reasons for it? What are the 5 main things it's trying to accomplish for the user? Test those, so you don't have an infinite scope.
Steve, same thread.
So in a similar vein, if I have a chatbot, well, you showed 2 examples, one that was not parameterized, but had a spectrum of answers. You could go basically from 0 to 1, and how close were you to either end? And you had a binary where it was either true or false. Since AI is not deterministic, how will I know, when would I use a binary? Because that's going to be pass or fail, but maybe it gives me a close enough answer. When do I know which one to use? When do I know the spectrum, and when do I know that I can use a binary on it?
If the feedback you get back is valuable. That literally is the answer. I know it's very it depends-y, but it's the truth. If the metric that you're getting back or the feedback you're getting back is actually valuable and helping you know the state of the AI, that's what you use. In the AI space, we'll use both. We'll use the binary pass or fail because you get failure rates that way. And then we'll use this gradient because you'll get gradients as well, and you can compare both. How many did it just get correct or wrong? And how good was it or how close was it in getting the right answers? So we would use both in our evaluations.
Bastian, same thread.
Yeah, it's pretty much the same I was going to ask, but maybe can you elaborate on, so the way you solve this is by having another AI judge the AI that you're about to test. Is there any alternative to that?
Yeah, we use all the things. So when I talked about this part, I turned off. But on this part, I talked about how I had hard assertions. You still have the automated tests for the easier checks, but there's also evaluations that you have as well. So notice how I said testing and evaluations. It's both of them. So I would say lean towards both. Testing is the easier one because it's very clear input-output, where the gradient is harder. It's more subjective. It's more, you need a human or an AI to evaluate that, right? So that's why we call it evaluation. It's not binary, where testing usually is.
Same thread.
Yeah, I just want to add on to the chatbot testing. We did a lot of that testing in our company. So one thing which we did was identifying the intent of the question and what is the response coming and flagging those accordingly, and whether the response is valid or not, putting an automation eval around it and having a bunch of guardrails to block the question, like unintended answer, or sanitizing the prompt in such a way that the response is relevant to the chatbot, which the chatbot is intended to build upon. That's how we controlled in terms of, how do we test the chatbot? What is the intent? Like the example you gave about Spotify recommender. If I ask, who is the current president? Why would that chatbot respond to that? It's a sad Spotify recommender. So identifying the intent and having a bunch of guardrails around it would help us with testing the response, quality of response in a way that we can definitely say that chatbot is working in a certain way.
Yeah, exactly. And that's that data labeling part on this diagram, right? So you ingest the data and you're labeling it in some certain way to help you with knowing where to put things through. So yeah, exactly.
New thread. Yep.
Hi. In one of my projects, we did a chatbot testing, and I have a question related to that. So in the first version, when this was coming up, the way we did testing was that, and there's some context, this chatbot was specific to departments' policies. So they had like huge policy documents. In non-AI days, they would like go through the whole policy to figure out an answer. But now with the chatbot, the goal they were trying to solve is that if I give you like a loaded question, the bot can look at the policy and come up with a customized answer. Now, the way we tested it at back in the day was we had like manual subject matter experts go through the answers of, let's say, 100 or so questions given to the AI and grade them the way you did, right? You know, is it good, bad, or excellent, something like that. But then in the new future releases, they would add more policies or the policies would evolve, right? So even if we thought of adding like an evaluator, I wonder how would that work, because you know the policy will keep changing, right? Or getting updated. Any suggestions on?
Yeah, so that would be a RAG problem. It's RAG because you already have the rules. Beautiful. That makes it so much easier because you're saying, here's the policies we have. It's only this finite list. Doesn't matter how big it gets. You have a finite list. Amazing. Because then for the AI that needs to make the decisions, it's here's the ground truth that you have. How good is it at using those? A hallucination would be it does something that isn't in your list of policies. Then that's a hallucination. That's a bad point towards hallucinations. For an evaluator, it also has that list. And so it can evaluate and say, hey, I know what the list is. Are you hallucinating? And it can do that as well. So having a definition is amazing because that makes it so much easier to do the testing for this. And I love that you say the chatbot was meant to help with these policies, because not just, oh, it's a chatbot. That's massive context. But if it's a chatbot to help answer questions with these, now it's so scoped, it's much easier to test because of that.
Thank you.
Yeah, so I love that. I love that. That's the right way to do it, yes.
I believe we've exhausted the stack. So thank you, Carlos.
Woo! Thanks, everybody.